Hello and welcome to another section in further mathematics. In this section, we'll be looking at the topic binary operation. But before we proceed, I would like us to do a quick review of our previous lesson. Now, welcome back. A binary operation is any rule of combination of any two elements given non-empty set. The rule of combination of the two elements of a set may give rise to another element which may or may not belong to the set under the condition. So when you talk of binary operation, the word bi means two. So for it to is an operation that involves more than one element, but it doesn't necessarily mean that it involves only two elements, but it's telling you that the minimum amount of elements that is involved in this should be two. So if you're dealing with only one, it's not a binary operation, because the word binary, it talks about two. So it tells you that the minimum element that should be involved in this operation is two. So that's where the name was gotten from, binary operation. It is usually denoted by a symbol. It is usually denoted by a symbol such as the star. Most times we make use of the theta in explaining it. But it talks about set of rules. That's everything about it. It talks about sets of rules that is used in the operation. A closure property. That's number one property of a binary operation. Now we talk about the properties. The first property is closure property. A non-empty set Z is closed under a binary operation this if all A, B belongs to Z. Example: a binary operation is defined on a set of this. Now this is a set of number 0 to 4. The set is equal to 0 to 4 by this is the equation that we use: x y x plus y minus xy. You're told to find 2 asterisk 4. Now this is the equation that was given to us. They now say we should find 2 asterisk 4. What this is trying to imply is that we take the value of our x to be 2 and we take the value of our y to be 4 and put it here to solve. So if you put it here now, look at what happened. It becomes 2 plus y is 4. 4 minus 2 times 4. So 2 plus 4 is 6 minus 2 times 4 is what? 8, which is equal to minus 2. So the value of our 2 asterisk 4 is minus 2. And this is what we have here. The explanation. Now if you want to do that of 3 and 1, you put your x as 3 and you put your y as 1. So let's put that into this equation. Our x is 3. 3 plus y is 1 minus our x is also 3 times 1. 3 plus 1 is 4 minus 3 times 1, which is 3, is equal to 1. And that's how we got this. And the last one is 0 and 3. So we now use the same. Don't forget, this is our formula. This is star asterisk, which is equal to x plus y minus xy. It was given to us because it's closed under here. We now have at the point 0 and 3. So we put 0 here. 0 plus our y is 3 minus 0 times 3. 0 plus 3 is 3 minus 0 times 3 is 0. So the value of this is equal to 3. So these are our values, and this is how we got to this place. So since -2, this point now, first point, because you are being told that x is closed under this point, this is the point 0, 1, 2, 3, 4. You can see that this point 3 is inclusive, 1 is inclusive, but -2 is not here. It's not here. So you now say since -2 is not a member of x, therefore the operation is not closed in x. Since -2 does not belong to s, is not a member of x. So that is to tell you that this operation is not closed in x. For it to be closed in x, all the members here are supposed to belong to the family of x. This is under closure, property of closure. Now when you talk about commutative property, they say if set x, a non-empty set, is closed under the binary operation for all a and b belonging to x, then the operation is commutative if this is equal to this. Now apart from this, the word commutative have to do with change of terms. Like if a plus b is the same value as b plus a, then a and b are said to be commutative, the addition. And if a times b is the same thing as b times a, then the relationship is commutative. That's what commutativity means in general. Example, the operation of x on set of real numbers is defined by this. Is the operation commutative? Now what I want you to test at this point, say commutative condition is p star q the same thing as q star p? That is to say, if you solve this and replace the value of p with q, will you obtain the same answer? Now if you do that, you discover that yes, it's commutative, because by the time you do okay, let's use this what we have here. Let's use 2 star 1, improving it. Let our p be 2 and q 1. So let's put it here. 2 raised to power 3 here is what? 2 raised to power 3 here is equal to 8 plus 1 raised to power 3 is 1 minus 3 times 2 times 1, which is minus 6. Now we now have 8 plus 1, 9. 9 minus 6 is equal to 3. That is for the first one. Now let's change it to 1 star 2. Now we are taking p first. Now even if you convert p first, so that is what you now do here will now become q raised to power 3 plus p raised to power 3. You're changing all the values of p and q. Minus 3 qp. If you watch, I've removed all the value of q and changed it to p. So with this we now have 1 raised to power 3 is still 1 plus 2 raised to power 3 is 8 minus 3 times 1 times 2, which is 3 times 2, is still 9 minus 6, which is equal to 3. So since the value of p q is equal to q p, then the relationship is said to be commutative. That's all about commutativity in mathematics. Now the next one is a closure property about non-empty set. If a non-empty set S is closed under a binary operation, that is this, then the operation is associative if this is this. Now you use the word associativity if A star B star C is equal to A star B star C. That is to say, at this point A apparently has associated itself to here. Okay, C associated itself and displacing A. That's the law of associativity. For example, we have to introduce another element. So associativity, let's say if this is equal to this, then we now substitute this as 2, then 2A plus 3B minus 1 plus 3C minus 1. That is from our question. Example, the operation this of integer is defined by this. Determine whether or not the operation is associative. So you have to bring about the third element. Now with this, if you have this star C, now our C serves as this 3C minus 1. So on solving, you have 4A plus 6B plus 3C minus 3. Now if you still do same to the right hand side by changing this and placing your value of your C here by placing 2A plus 3 at this point, you discover that you still arrive at the same answer of 2A plus 6B plus 3C by this. But if you check it here, you have 3C minus 3, and at this point is 9C minus 4 when you've interwoven the value of C. Because if you displace A at this point, this is what you have, 2A plus 3. That is when you have A. And when you displace, when you now substitute with B, you now have, with C, you have 9C plus this. So this is not associative. Most times, binary operations does not usually obey the law of associativity. So once more, let's talk about distributive law. Now, distributive law in a binary operation have to do with, for example, if you have 4 in bracket A plus B, distributive law will show you that it is equal to 4 times A plus 4 times B. That is, 4 has actually distributed himself to A and B. That is what distributive law is talking about. So we can apply it here by saying, given the set R of real numbers under operation this and this, defined by this, where A theta B is 5AB for all A and B belonging to R, does this distribute over theta? Now this is the question. You know that B theta C was not given to you, but you were being given A theta B. So with this, you now have it that your A star, now instead of your B, you now have your B theta C at this point. Now you want to check if it's actually distributive, because this is the law of this. This is how to check if that you have the A operation B theta C is equal to A theta B theta A and C. So whereby our A this is equal to B theta C and is equal to our A 5AB. You know what we got our 5AB from A theta B. This is it, from A theta B. So AA goes here, then A and B gives you this. So after that, we've gotten our A plus 5AB minus 3 by obeying the law of distributivity of this. And it was actually clearly given to us. So you now do your A star 5AB in terms of multiplication of the inverse, but our AB here covers the position of the A plus B in terms of closure, just like what we did in the first listing. So we have this point. Now if you do that of this, you discover that you're having 5A plus B minus 3 and this. So from the expansion, it is obvious that this is never distributive. So one thing about being distributive is for you to just know the law that specifies that for a property to be distributive, it talks about the constant being multiplied and distributed among other variables. So I would like us to summarize with identity element. So when you talk about identity element, it talks about an element that assumes a constant. So that of an identity element must either be a positive or a negative sign, but given a non-empty set X which is closed under a binary operation, if there exists an element E belonging to S such that A is equal to this and EA is equal to A for all this, then it is called an identity or neutral element. The element is unique. So this is trying to show us that the element must be definitely a positive number. But in order for you to check it, it's as simple as that of closure. The only thing you need to do here is, since we have, look at the law, A dot E should be equal to E slash A and should be equal to A. Now, we have a question in front of us now. They said A dot B is equal to 2A minus 1 over 2 plus B. This is what was given to us as A dot E, as A dot B. Now let us check A dot E. You just have the same thing by substituting B with E. So you now have 2A minus 1 over 2 plus E. And let's check if it's equal to A. Let's see, equals to A. Then let us solve for the value of our E and see what we have. If we can solve this and have a value of E as being a constant term, then the law shows that it is an identity element. So with this, we now have 2A minus 1 plus 2E is equal to 2A by taking LCM. The LCM here is 2. So we have 2A minus 1 plus 2E. Then we now cross multiply equal to A. We now cross multiply. We have 2A to be this. So at this point, we want to make E subject of the formula. So if 2E goes to this side, it cancels off. So we now have 2E to be equal to 2A. Then this one goes this side, minus 2A. And minus 1 comes this side to become plus 1. So our 2E is equal to 2A goes with 2A is equal to 1. So the value of our E is equal to 1 all over 2. Since our E have assumed a constant term, then the binary operation is closed under this. So it's an identity element. And we are rounding up here. So when you talk of inverse element, it's just the inverse of the identity element. For example, they said an operation X is defined on the set of real numbers by this: y equal to x plus y minus 2xy. If the identity element is 0, find the inverse of the element. So what they just need you to do at this point, you're looking for inverse. So our y becomes x inverse at this point. So it becomes x slash, instead of y, this is what you're looking for. So which is equal to x in place of this, which is equal to, you can now see the value of your x here is still x. Then your y inverse now is now minus 1 star x, which is equal to identity element. And remember, identity element is O. So when you now substitute it into solving, you now have your x prime bar, which is 1 minus 2x, which is equal to minus x because of the value of this being 0. So the inverse of x becomes equal to minus x over 1 minus 2x. So, and this serves as our inverse element in this. So I would like to say thank you for being part of this lesson, and I really know that you've really gained a lot on this. So take the test that will be popping up very soon on your screen. Do well to give us feedback on the subject.